Good morning, ladies and gentlemen, Algebra 2. Good to have everybody here, except for Zach. Welcome to room 15, where learning never ends. I'm still waiting for my t-shirt. Maybe it'll come in today. If not, I'm not going to wear it tomorrow, because what t-shirt am I going to be wearing tomorrow? Tie-dye, right? So I may have it here, sure. So anyway, we were working on domain, range, and end behavior, and the different types of notation. And so today we're going to be doing exercises on those. And let me just hand this out, and I'm going to preview some principles here. Yes, you're welcome still to come in and retake the test. I've had from this class, I think just one person come in. And from the other class, I've had 3 people come in. So that's an available thing. I don't think Gio may want to be doing that, or Tyler. Maybe some of the others. I'm telling you, in this section, just so you understand, I do not see what is really difficult. I mean, other than the types of notation, because you're being introduced to new types of notation, but other than that, I don't see anything that's really difficult in here. Oh, also end behavior. So there are some new things you're introduced to, but this just thing, and I'm telling you that this section here, for my Algebra 2 honors course, is one of the, maybe the hardest section they're going to be facing all year, you guys. So I just want to tell you that if you think you're kind of floundering here for a little bit, it's not just you. This is what I'm telling you. It's not just you. So, and that's one of the reasons that we started out on chapter 7 first, to cycle back to this. Just as a preview, we had one of our Algebra 2 honor students who actually put a guide together for this, and this is a guide that helps us kind of work between the different types of notation. Okay, so we're gonna come back and refer to this. Here's greater than or equal to. This is inequality symbol. X is greater than or equal to whatever. And also the arrow in these inequalities points to the smallest number. So this over here is going to be greater than this. This over here is going to be less than this side. So if you just look at the arrows, so you can see for here you have inequality notation, number line notation, and down below you have interval notation. So those types of symbols. So what I want you to do is go to problem number 1, and you're given this number line notation, and you're asked to write as an inequality, set notation, and interval notation. And set notation is what? Set notation is just inequality notation, but with all those curly bracket things, right? And the x such that x is greater than or equal to whatever. So that's what their set notation is. So I want you to work on this, talk to neighbors, see if you can get the set notations on. I'm going to call on somebody for this one in 2 minutes. We called in the first period on this one. I called on Trevor, who was sitting right here. He did a good job. He had 2 out of those 3. Had the harder ones, by the way. Is there anybody who feels like they don't know what they're doing on this thing? You don't?
A little bit.
A little bit? Want you, you don't, okay. Can you talk to a neighbor? Do you know what's going on here, Rowdy? No? Who understands what's happening here on this? Anybody? No one?
I think we're all equally.
Not a single person, not a single person. Seriously. Logan?
I don't
I don't-
fully understand it, but I'm not like
I don't
clueless.
get the squiggly line one.
But you get the other ones?
I mean, I get the bracket and parentheses one.
Okay, here's what I want you to do. Let's do this. I'm gonna make an executive decision. What I want you to do, Tyler, I want you to go up here and show us what you figured out so far. Can you do that?
I.
All right, he says, all right. All right,
Woo. You're good.
all right. So here we have the, we have this, I appreciate that, but we need to fix this up a little bit.
Shouldn't the symbols just be flipped?
Let's go look at the guide here, right? So we want, what happens is, we have greater than or equal to here. So just looking at that, greater than or equal to is gonna be equivalent to a bracket. So we're gonna go ahead and fix this here. This is gonna have to be a bracket. Okay?
Because it's greater than you
So if it was an open circle, it'd be parentheses?
Yeah, open circle would be parentheses, okay? And here's another thing, is that when it comes to infinity, you are never equal to infinity, so next to infinity always has to be a parentheses. Okay. So this right here is called our interval notation. And then set notation, well then there's inequality notation. It says inequality. Inequality, we have this right here, this 5. So what we have is greater than or equal to 5. And so the way we have to write this is x is greater than or equal to 5, but less than what?
Infinity.
Infinity. Or another way you could write this that might be easier, you can just write x is greater than or equal to 5 like this. So either one of these is correct for inequality notation. This one here is more economical and simple, right? And then set notation is simply this. You just take, it's just going to be x such that, so you take either one of these and just plunk it down there. X such that x is greater than or equal to 5. So this is your set notation. This is your inequality notation. Are the lights starting to flash on in the brains on this?
I'll light it now.
Or is the light still out?
Still,
So,
it's getting big, 7.
Getting there?
Still out.
It's still out.
No, still.
Don't let it raise, man.
Try the bulb.
So you feel like you're being asked to learn a new language, like you're trying to learn Chinese or something like that?
Yes.
Okay, well, I don't know. But the thing about it is, at this stage in your mathematical career, you should be already thoroughly acquainted with this thing right here, with these inequality symbols in language, right? You should be, I'm not saying you are. Okay. let's go on here to number 2. Now here you're given an interval notation, and you can refer back to Ashton's guide here. This was Ashton's idea to write this down. So you can refer to this guide, and if you refer to this guide, is that going to help you with problem 2? And problem 3? And problem 4?
No.
It should. Right, here's a parentheses, here's a bracket, here's a 5, here's 100, here's a comma. So you can get your inequality. What I would do for this, I would get your inequality first, and then build from inequalities to your set notation. I'm going to call it something. Help your neighbor, help your neighbor. Okay, for this one we have Carly. All right, Carly, what do you have, Carly? All right, and talk to neighbors if you need help. I don't know who's going to be in this to help you. Maybe Tyler, Logan,
Sir?
Help Carly.
Carly, maybe. I don't know who else. Gio. Gio's pretty quiet. Do you understand what's going on here, Gio? Kind of. Who feels like they understand what's going on here now? Anybody? Just too modest? Or seriously?
I don't know. Oh, yeah, that's what I would. Yeah, that's it.
So the inequality, that 5 is less than or equal to X.
Okay, so Carly is telling me she got 5 is less than or equal to X, is that right? And then what else? What about the 100?
For the set notation, we're at X, well, there's a little bracket things, and then X, such as X is less than or equal to 5.
Less than or equal to 5? Well, let's take a look at our guide here. Okay, what we have is we have this, right? It's parentheses? Oh, so it's parentheses, right? and then it's 100 bracket, right? So let's look at this. So this parentheses is equivalent to what? These, right? So it's going to be greater than. So we come back here, and so it's going to be greater than. So x is going to be greater than 5, but we have this bracket here, which means x is also going to be less than or equal to 100. So how do we put all this together? Okay, we have this, and we have and this, right? So how do you put all these together in one consistent statement? Start with what? 5, and then what? X, and then what? Better less or equal to 100, okay? So we have that, and now what can we do with this? Put this right in here, can't we? So we can just insert it down below. 5 is less than X, which is less than or equal to 100. Okay? Does that make sense? Isn't that guide helpful? I think the guide is helpful. To me, it looks like. I want to thank Carly. I want to thank Seth. Maybe others. This shouldn't be that bad, right? Questions on this one? Okay. How many are catching on to this now? Because Seth, you must be. No? Well, you're the one who said it. Weren't you the one who said it?
Yes, but
What about Tanner? What about you? You see it? Slowly? All right. All right, let's continue on. I want to thank you, Carly and Seth, especially, for that. It's not easy to be put out here on a limb like this. So the 3 are given the inequality notation, and then you're going to try use that to get the set notation and the interval notation. So go ahead and do that. I'll call on somebody here in a couple of minutes. Tyler has the interval notation on this one. So Tyler can help you on this one if you need help with interval notation. Welcome to room 15, where learning never ends. Okay, yes, I will send her promptly. Bye.
You like getting phone calls, Mr. G?
Sometimes if my phone hasn't worked. That was a little fuzzy. Okay, this one we have Cora Gale. You are the young lady of honor on this one. And Maddie, I need you to go to the office and get your, yeah.
Oh, okay, well, I didn't know. Do I have to go up there now?
You don't have to, it just makes the class better if you do, that's all. You've been good at that in the past.
Better,
That's
that's the wrong
better.
answer.
Wait, make it
Corville's gonna go up there. Should be.
Is that all I do, or I do the other one too?
Yeah, you can do the other one too, right?
That's a negative? Why?
It says negative 25 right there.
Oh, I thought it was just a mess up.
If it's
Who caught the negative sign there? Good job, man.
Good job,
Excellent work, man. You have good eye for, what kind of eye, do you have good eyesight?
QBS.
You have good eyesight? All right.
You got the quarterback.
Probably the worst
All right, really good. Good catch.
awesome.
Somebody asked me that first period.
Oh, it's fun, the white guy. I'm dead serious. I think I'm playing. There's not a lot of
All right, what do you think? You think that's pretty good? That's really good. Let's just go with one more thing here.
Oh, the negative.
Yeah, it's just this, right?
My bad.
There we go, right? So now we're good, right?
I'm getting the hang of it, Mr. G.
Yeah, that's the idea. We're trying to just kind of, the train is going, people are gradually getting on the train as we go forward, right?
Wait.
Just put it in the thing, because it gives you the implementation, so, or whatever. What is it that it, the inequality? Wait, yeah, once you get the inequality, you just put it in.
That was like X, such as X is. I get what you're saying, but I thought it was
Eagle eye.
on set notation. I thought it was X.
How do you know
such as
which
X
one
is,
is, if it's greater than or less than?
greater than or equal to negative 20, or, yeah, negative.
How do you know
or
what's
less
which
than?
one to use?
That's-
Yeah, now here, so Logan is mentioning something here. I want to go ahead. There's another way you could do set notation,
It's the same thing every time.
kind of a combination of things.
And then the top.
You could also write it, the set notation, you could do this.
Bottom one.
You can write x such that x is greater than or equal to negative 25. But then you have to take care of this, right? And x is less than 30, right? You could do that, but what's awkward about this? It's not as efficient as wrapping it all into one statement, right? So this one here, and this one here, Corrigan sandwiched the x between negative 25 and 30. So that's why you don't ever see it written like this on the bottom. Because logically this makes sense, right? And that's what you were saying. Isn't that right? Logically this does on the bottom make sense, but this one here that Corrigan wrote down is more acceptably practiced. Let's say that, okay? Was that your question?
Yeah, so like if you wrote the bottom part on the test, would it be wrong?
Probably not. I would just say, nah. Logan was he was just kind of awkward. So yeah, this one here would get the essence of it. It just has more. It's not as symbolically efficient
It's not
as
like-
Corrigan. I guess that's the way I would say it.
It's not a, would you not consider that like standard form?
Or another thing you can do instead of and. A lot of times you'll see instead of and you'll see a comma. X is greater than or equal to negative 5, comma, x is less than 32. So that's possible too. So yeah, there are different ways of getting things correct. And so that's kind of, I hope that's a takeaway from this. Do you follow along with what Logan's saying there? Okay, I hope you do.
No, that would come weird.
Okay, but sometimes, remember Logan, what I said about doubters and haters?
I
Remember?
feel like you're not living life right if you're not haters.
Okay. Well, it kind of depends on the venue of competition you're at, really. Okay, and this one here, we have Maddie. Do you see what's going on here, Maddie? No? What we lost? So we got an option here. We can, Maddie can get help, or I can call somebody else. What do you wanna do?
Call 1-800.
Yeah, Corgale could help you. Corgale's right, sitting right next to you.
Yeah, Miss Cornell.
She was helping Nate a minute ago. She's up here working a problem, last problem 3.
So then I'm not sure that's how people do math, because I'm like, here's an answer.
Wouldn't be
I don't know how to explain.
Yes.
And you use this little thing, and there's not a line.
Like last year, you know, math would be like, oh, no, I'd be like, X squared, slip in the answer. I don't know how to.
Let me see what's on your shirt today.
You can just take what's in this, and this one, and put it down there, minus that first one.
I'm more familiar with the pink folder.
So, I'm going to match plus -30, that's the next. Because that's what.
I think you're asking me, sure.
But there's that.
Two thirds. You just gotta put
Oh,
your high
this is X, that's that,
The operating circle.
So, Madeline, are you okay now?
I know it's a hybrid.
I just.
I like them back on.
Now we're out the next on the roof.
Yeah, I played the loop
This
down.
is the
Like that? Two guys out?
I'm gonna take, what I'm gonna take is I have Madeline's paper right here. So this Madeline's paper right here, she has this. And I'm just reading off the paper. That's all I'm doing. So does that look right so far? You know, what it is, it's just this thing here, isn't it? It's just this thing just transferred here like this. Then the last thing is interval notation. So again, just reading off her paper here. Does that look right?
Yep.
That's
A little bit.
Nice.
All right, good job.
Almost.
Forgot the brackets. So the bracket thing, what?
So that's, again, this isn't that hard, is it?
No bracket either.
And then we get to
I think
this.
now we should take a survey on who understands it or not.
Okay, yeah, that's good
Bob
thing.
got a haircut.
Who thinks you see what's going on here now pretty well, right? See what's going on here? But this whole thing about being called on, right, it's a learn by doing exercise, right? Thank you. Okay. Okay, let's go on to number 5. Okay, what happens is, this one here is, what I want to do with this one is, I think, you want me to go over this one here?
Yes.
Yeah, let me go over this one. I did that for first period, just kind of what we learned about first period. Okay. So 5 through 8, write the domain and range of the function as inequality using set notation, interval notation. Also describe the end behavior of the function. Describe or explain why there is no end behavior. And here we have this graph of this function shown. And so the first thing we're going to do is put domain range. So domain, what's going to be our domain of this function here? What do you think? What's our domain of this function?
Infinity.
Okay, the domain, what kind of function is this? It is a
Quadratic.
quadratic function, very good. And the quadratic function is a dues-paying member of what larger family of functions? That I mentioned it. What did you say?
Polynomials.
Polynomial functions, thank you. Did you say that?
She was trying
Yeah,
to.
she said it. She didn't quite call it. I didn't hear her as well as I heard Preston. That's all right. Okay, yes, polynomial functions. And what is the domain of this polynomial function and all polynomial functions in the mathematical universe of polynomial functions? All real numbers. Who said all real numbers? Yes, thank you.
I thought you said it can't be all real numbers if it doesn't have like any, like the line doesn't go through negative and the y side.
Well, we're gonna get, you're talking about range at that point,
Oh,
right? Because we're not definitely, you're bounded below, right?
So all real numbers for domain is because it goes through both negative x and positive x.
Yeah, so all real, so that's why. So it says inequality notation, so it's gonna be like this. Right? And in set notation, it's gonna be x such that, you just plunk it right down in here, right? Same thing, just go ahead. And lastly, interval notation is,
It would be parentheses, negative, infinity, comma, infinity, parentheses.
yeah, okay, good. All right. The next, range. Range is going to be, now in this case, we do have, like Lola was mentioning, right? We do have a lower boundary here, right? At y equals 2. So what is our range going to be? Y is greater than or equal to 2. So to me, this is a good way of writing it, maybe the most efficient way of writing it. Also, you'll see it written like this sometimes, like 2 is less than or equal to y, which in turn is less than infinity. I think this one on the left is a little more efficient way of writing it, but each one of these is equally valid, all right? And then as set notation, it's going to be what? Y such that y is
Less than or equal to?
y is greater than or equal to 2. Or you could put this in here too, right? And then interval notation is going to be like this. And then finally it says end behavior. And that's as x approaches infinity, f of x approaches as x gets bigger, what does y do? Which way is y going? Up or down? Up. So what goes here? Infinity. And then, what about in behavior the other direction? As x approaches negative infinity, f of x approaches
Hold on, It'd be infinity.
Negative infinity?
No, wouldn't it be infinity? 'Cause
Yeah.
both arrows are going up.
yeah, both arrows. Okay, this is one of these. This is one of these where we said we are.
Oh, touchdown's good.
We're starting high and ending high. So end behavior is both infinity either direction we go. As x approaches negative infinity, infinity. As x approaches positive infinity, infinity. Touchdown!
So we're gonna send Friday night.
Score! Hope so. Or would you guys play Thursday though, right?
No, I'm talking about for.
We're talking about these other guys, right? But you guys go on the road tonight, right?
Usually.
All right.
Usually.
Okay. Here's what I want you to do with class today. I want you to go work on this one. This is supposed to be f of x equals 3 to the power of x. Is that what shows in your paper? Should be f of x equals 3 to the power of x.
I can do the power.
So what I want you to do is work on this, and what we're going to do is we're going to pick up on this tomorrow, right here.
So, work this out.
Yeah, just go ahead and work this out by yourself right now, and then we're gonna resume on this tomorrow. And part of it is kind of where we end with the other class. For some reason, this class, we get through stuff faster, and I think what it is, the time of the class is the same, but what happens is it's sort of getting started with the school day, kind of brings in some extra overhead that takes time. Plus, this class is really efficient, going over stuff, so that's fine.